Welcome to this video lecture on Chapter 10 of the textbook, which will discuss ordinary differential equations and more specifically initial value problems. When looking at the overview of the course material, we see that we have reached the end of the 2WN50 course. We've covered quite a lot of topics so far, and now we will apply some of those topics in the last one, which will deal with ordinary differential equations. Now, it is quite a sizable chapter. Also, these videos will be quite a long video in total, as there is a lot of material to cover. Here we have an outline of what we will discuss during these videos. Similarly to what we've done for all the other cases before, we will start with a background and some motivation on why these kind of equations or initial value problems are important. And then we'll discuss some basic numerical methods for solving ordinary differential equations or initial value problems. In section 5, we will discuss Runge-Kutta methods, but the Runge-Kutta methods are not explicitly part of the exam material. But I believe that a discussion of numerical solution of ODEs is not complete without only mentioning the Runge-Kutta method. So I just mentioned them for your information, because in practice, those are probably the most common methods that you will use in reality. We'll discuss how to generalize this to a system of first-order ordinary differential equations, and generalize this also to solving higher-order initial value problems. Again, solving higher-order initial value problems is not really explicitly part of the exam material, but I believe it is worth mentioning. After that, I changed the order of the topics a bit in comparison to the textbook, because I find this to be much more logical. So after these higher order problems, we'll discuss stability and what it means for an initial value problem to be stable, but also what it means and what the requirements are for a numerical solution to such a problem to be stable. We discuss a class of ordinary differential equations for which these stability requirements are very restrictive, and those are stiff ordinary differential equations. And we'll show the specific methods that can be used in order to solve these efficiently. And then we finalize with the MATLAB built-in functions for solving initial value problems.